All right, so for this game, it looks like we have what is essentially just a straight kind of sequencing game. So we can set it up accordingly. We have 6 spaces to work with, and we are going to have these 6 people that are going to be assigned to these positions. We have R, S, T, V, X, and Y. Now, it's worth noting right away that nothing weird or out of the ordinary here. Everybody just goes exactly once into one of these spots, so we can just go straight to the rules. So the first rule tells us that Y has to go in a higher numbered parking space, and it's worth noting that in these rules the wording is very literal, higher numbered. So these 6 is higher number than 5, and so on and so forth. So basically that means that T has to go essentially earlier than Y. Next, we are told that X has to be higher numbered than S. So in other words, S is effectively, for our purposes, before X. Next, R has to be higher numbered than Y. So R has to go after the Y. And we already have a Y on the board, so we may as well take advantage of this. We can say that we're going to have kind of this T, Y, R setup. And lastly, we are told that R has to be in 1, 2, 3, or 4, except wait a minute, we already know that R has to go after these 2, after T and Y. So really there's no way that, there's no way that the R is going to go into 1 or 2. So really this is just a roundabout way of saying that R has to go into either 3 or 4. In fact, this might not be a bad thing to exhaust, because essentially R can only go into 2 positions, and if you put them into 3, then T and Y get locked into place, which is great. And if we put them into 4, we might be able to do a bit more. But yeah, let's run it. We can say that there's 2 major plays. Either the R is going to go into 3 or the R is going to go into 4. Now, top scenario, T and Y are going to go into 1 and 2, obviously. And I suppose as far as the last 3 positions are concerned, they're a bit more flexible, although we can just kind of write in what we know is going to happen. We're going to have a V somewhere over there, and then S before X to some degree. We just don't exactly know who's who, but basically those guys are just going to roughly shuffle on that side of the board. Now, in the bottom scenario, I suppose we have a bit more flexibility, because V, for example, could really move wherever. V has no rules on him, and yeah, I guess S could even go somewhere around here. So it looks like it's a bit more flexible. So you know what? Let's see what we can do with what we have. So the questions themselves. The first question is our straight exclusion question, and we approach these by the original rules. So first rule, we said that Y has to go higher, or in other words, later than T. So answer choice A, well, I suppose that gets rid of answer choice A already. Y can't go first. B looks okay. Y is after T. So is C. So is D. And E looks good as well. Next, X has to go higher than S. So same kind of deal. Answer choice B, X is last, so that's fine. C, X is before S, so that's not going to work. We can get rid of answer choice C. D has X towards the end, and so does E. We're good. Next, we are told that R had to go higher numbered than or later than Y. So let's take a look. Answer choice B has R later, so we're good. Answer choice D has R in second. That's definitely not going to work. And answer choice E has R later than Y. We're good. And lastly, we're just down to B and E. R is supposed to go among the first 4 positions. So answer choice B has R in number 5. Not cool. So that leaves us with answer choice E as the best answer to question number 1. And as usual, I suppose let's just kind of plug that into the board. So answer choice E has STY followed by RXV. All right, so from there, let's take a look at the locals. So question number 2, if T is a higher number than S, well, I suppose if T is higher than S, so we can say something like, we're going to have S before T. Right away, that means that this scenario is out of question, right? This we can't do T in number 1. So we're going to be in this scenario right here. And I guess we can plug in the R into the 4th position. And I suppose what else do we know? Well, we know that the T is going to go before the Y, right? So we're really going to have an STY setup, all of which has to go before the R. So really, they're just going to go into 1, 2, and 3. So that's pretty good. And that leaves us with who? We just have v and x, and I suppose they can go either way. They'll just shuffle between positions 5 and 6. So to the question, which of the following now could happen? Answer choice A, y is in number 2, and no, that definitely can't happen. Answer choice B, v goes to number 5. And actually maybe, yeah, these guys could flip back and forth, right? They could go either way, so let's hold on to answer choice B. Answer choice C, t goes to number 3, and no, that's not happening. Answer choice D, s to number 2, nope. E, r to number 3, definitely not. Best answer to question number 2 then is B. Next, question number 3 and 4, these are global. We'll come back to these in a second. Let's take a look at number 5. If y is assigned a higher number than s, so for this scenario, we're going to have the s before the y. Now, again, if s is before y, then this is out of the question. We can't have this t, y, r in 1, 2, and 3, so r is definitely going to be in 4. We're going to be in the second template. And otherwise, I suppose what we know is that the y still has to go after the t. So effectively what will happen is that in these 3 positions, we're going to have the y in the 3rd slot, and then s and t are just going to shuffle between 1 and 2. That's a bit more flexible. And as before, v and x are just going to shuffle between 5 and 6. So to the question now, which of the following could happen? T is in 1. And actually, yeah, t could potentially go into 1 right now, couldn't it? So let's hold on to answer choice A, just in case. Y is in 2 and definitely not. R is in 3, definitely not. S is in 3, nope. And V is in 4, nope. Best answer to question number 5 is A. Next, number 6. Let's take a look. If R goes into number 3, well, actually, I guess we don't really need a new scenario here, because if R is in 3, that just locks us into this top scenario, doesn't it? Because y and t are going to go before, and these guys are just going to do their thing. Let's just go with what we have. The question asks what now must be true. S is in 4, and not necessarily, we don't know that. T is in 2, not necessarily. V is in 5, we don't exactly know. X is in 6, again, we're not sure. Y is in 2, and yeah, that definitely has to be true. Best answer for question number 6 is E. Next, let's go back to the global questions. Question number 3. The assignment of spaces would be locked if what was true, so what would lock down the game? A, S goes to 1. Now, it's worth noting that we've seen scenarios like this one, where S was in 1, but V and X was still flexible. So that right there would be enough to show that putting S into 1 is not going to completely lock the game. Answer choice B, Y goes to 2. Now, actually, I guess if you look at the first template that we had, Y was in 2, but these guys could still shuffle, which means that that's not enough to completely lock the game. Answer choice C, V is in 3. Now, this one we haven't actually seen explicitly yet, but I guess, okay, if we look at the templates, for V to go 3, it would have to be in the second template here. Oh, actually, wait a minute. If we put the V over here in 3, then T and Y, which have to go before R, are going to have to go into Y in 2 and T in 1 respectively, right? And that just leaves us with S and X, but then they're going to have to go in that sequence for positions 5 and 6. So that would work. V going into 3, once again, if you put V over here, you'll have to put T here and Y there, and then S before X would force S in 5 and X in 6. That would lock the game. Best answer to question number 3 is C. Just in case, let's take a look at the rest. Answer choice D, R goes to 4, and no, because in this scenario that happens and that's wide open. In fact, we've had several scenarios where R went into 4 and there was still flexibility, so that's certainly out. And E, X goes to 5, and I suppose you'll notice that, for example, in this scenario, if we had put the X into 5 and V into 6, these guys could have still flipped, so that would not have been enough to completely lock the game. So once again, best answer here was indeed C. Lastly, question number 4. For how many of the employees is the spacing limited to one of only 2 possible spaces? So we're looking for basically how many of these guys can only go into 2 different places. Now, the first thing that should kind of stick out here is that these guys, T, Y, and R, are basically all down to 2 possibilities, right? R can only go into 3 and 4, but the other two, they just shift over by 1 position. Y can only go into 2 and 3. T can only go into 1 and 2 because of their sequence. So we know that we have at least 3. We have T, Y, and R that are limited to only 2 possible positions. Now, as far as S, V, and X are concerned, I suppose V, we can start with V. V is really flexible, isn't it? Because, I mean, in this scenario, for example, V could have easily shuffled between 4, 5, 6, and then S and X would have fallen into place. And in the second template, I feel like V could also have gone anywhere here, because you could have put S over here and X over there, and then V can just kind of chill over here with the other guys. So V is not an element that's down to 2. It has a lot of possibilities. S, now S kind of has the same thing in the sense that S could arguably go between 1, 2, and 3, couldn't it? Because, I mean, we've seen it go into 1, we've seen it go into 2, but we could have shifted the T and the Y. If we did T here and Y there, then S could have easily gone into 3, right? Or we already talked about how S could go on this side as well. So S is not limited down to 2 possibilities. X, what about X? And, well, actually, you'll notice that X actually is kind of restricted, isn't it? Because in the top scenario here, there's no way to place the X in 4, obviously, because it has to go after S. So X would have been stuck between 5 and 6. But in the second template, there's also no way to put S among the first 3, because if you put an X among the first 3, then there's no space to put the S before it and the T and the Y, which means in the second template, X is also stuck between positions 5 and 6. Which means X is also limited to just 1 of 2 possible positions. The best answer to question number 4 then becomes answer choice D.